Hello, good morning, good afternoon, or good evening. Welcome to today's webinar. I will give another 20 seconds or so for everybody to join in, and then we are gonna start.
I like that. Hey, Miss
great.
Scarlett, you're looking good today.
Oh, thank you, gentlemen. You too, I must admit.
Yes, let me quickly look. Yes, this looks good.
Okay, welcome to today's webinar. I'm Elisaveta. I will be your host, and today's Miss Scarlett from Plum. Before we start, I would like to introduce a few housekeeping items. First of all, this session is being recorded and on-demand version will be available shortly after we finish the webinar. You can submit questions on the right side of your screen and we will try to answer them either immediately or by the end of the session. And please also check the handouts panel for some valuable resources that we have uploaded there. So today we are diving into the mysterious world of Kubernetes with our interactive Kubernetes Challenge Workshop. And here you are joining us to solve complex application mysteries in real time with StackState. So you can get ready for a session full of mystery, discovery, and very important, a chance to win one of our 450 euros Amazon gift cards. I would like to also introduce my gentlemen. Today with me, I have moderators, Jeroen van Erp, who is our Technical Alliance Director, and specifically today, Professor Plum, and Andreas Prince, who is the CEO of StackState, and today a Kernel Master. Andreas, would you like to kick this adventure off?
Well, I was just smoking a nice pipe, so why would we go into a challenge workshop today? No, all jokes aside, I'm definitely happy to do that. Predominantly, it will be about you today. So that is really interesting. It will be you behind your keyboard doing a lot of live sessions. I'm absolutely not the expert. I'm just a lover of good pipes. And Professor Plum, aka Jeroen, will guide us through. So we actually want to do a little bit of theory. Then Jeroen will do a very brief demo just to understand the navigation of StackState. And as soon as that is done, it's your turn to take the keyboard and actually do. So if you want to eat a sandwich because you're in a region where it's lunchtime right now, definitely do that in the first part when I'm a little bit of speaking, because after that you really need your mouse and keyboard to navigate through StackState. But more about that in a little bit. Let's chat and briefly talk about 4 different challenges that we've seen at all of our customers and prospects. Some are bigger, some are smaller. Let's get to the first challenge. The first challenge is, if you think about observability, it's obviously all about interpreting data, or if you like, interpreting signals. And the first challenge many software development teams face when they have the responsibility to observe their business application is that they are trapped in the telemetry web. The telemetry is all siloed. And when we speak about telemetry, you can think about metrics, events, logs, and trace as a kind of the most common data types that you need for observability. But at StackState, for example, we also recognize Kubernetes configuration information, or we recognize change information, or we recognize security signals or CI/CD data. And all of these different distinct telemetry types are often siloed. And that means that it's, first of all, hard to get access to. And secondly, what we see is that there are numerous solutions in place to get insights in metrics, or insights in logs, or insight in trace information. And then the question is, if you need these 4 or more data sets, how do you actually get to a good understanding of what's going on? And that's why, and that's what you'll see in the demo and will experience yourself, by bringing that data together, you can much better solve issues and therefore reduce MTTR, mean time to recovery or to repair, as some would say. The second challenge is probably equally interesting. And that's not meant negative, but that's what we call the dashboard pitfall. Because our brain is so wired in the last 10, 15 years when it comes down to observability and monitoring, is that we are extremely dashboard oriented. However, with the dashboard, you're still not getting the full picture because often only a few data types are coming together. And probably more important, does a metric or does a log line or does a trace as a distinct component tell you what needs to happen? And what we've experienced is that although we love to see dashboards, they're colorful, they're insightful, they not often help you to answer the question. And at StackState, we believe that to do effective troubleshooting, and if you really want to solve the puzzle that Professor Plum will solve in a bit, and I did recently as Colonel Mustard, you need a bit more than just a dashboard. I will come to talk about that really briefly. The good practice, however, what we see is more and more SRE teams or platform teams understand the need that a central team having all the knowledge available can be a facilitator for the organization to create best practices that can be distributed amongst the teams. And that's also something that we believe in. If you have a few experts in your organization, as a manager or as a software developer or as a platform team lead or member, you should ask yourself the question, how can I use this information to let others solve the clues? Because remember, we're solving puzzles here. So how can your knowledge be beneficial for a bigger group of engineers? A dashboard is helpful. A remediation guide, as what we will see in a bit, is equally helpful there as well. If we take a look at the third challenge, I touched upon solving puzzles, interpreting signals from a dashboard, but there's one more kind of thing to really understand. Imagine your organization has a platform team providing the base level of your cloud infrastructure, either self-hosted or in a public cloud. You have SRE teams having knowledge of application optimization, troubleshooting. But then there is that big group of software developers who develop software and deploy that towards that infrastructure layer, if you like, the cloud layer. The important question is, how do you turn these software developers into really fast issue remediators? Because if you believe in you build it, you run it, then the question is, what is the type of knowledge you need to have? And we have encountered that there are actually three types of knowledge lacking in many teams. One is they're not necessarily an expert in Kubernetes because they're an expert in software development. They need to develop applications. So the question is, how can you build an observability solution that takes care of the Kubernetes knowledge themselves? And that is really important because then they don't need to know what a pod, a container, a node, a cluster, a master node, a worker node is. No, that's captured in the tool and they just utilize that. It becomes easier to navigate if the tool takes over the setup of Kubernetes. That's the first one. The second, also very important one, is what is it that I actually need to do from an observability perspective? They can do some application level thinking. What are the business metrics I want to observe? Because they are an expert in that field. But when it comes down to more technical, lower level observability, where do they get the expertise from? That's the second knowledge gap that we identify. And the third goes a little bit broader than just regular health reliability or health of your application. It comes down to interpreting security signals, for example, from your container scanning tools like Falco or NoiVector, or interpreting other signals from a security perspective as a part of your holistic observability. And also there the question is, can you as an expert team facilitate that towards your regular software developers who deploy towards your cloud platform? So that's on knowledge. And then there's a fourth one, because this is still residing more or less on the technical. Let's go to the last challenge. These three roughly reside at the IT side of the house, the developers, the platform team. But what is really important to understand is that it has a humongous impact on your business, and predominantly on business velocity, on business risk. And this is why. If you struggle with your engineering teams in the broader picture to remediate issues, the longer it takes, and there is an issue, the longer there's impact on your end users, on the business. And that puts your reliability as such at risk. There's waste in the process because you need to involve numerous people to start solving a particular problem. So if people are involved in solving issues, and probably not the right one to solve it, but they're anyhow involved, you're not focused on development of new features. So that means there's a drop in velocity. And believe me, and I've been an engineering manager myself, often your most senior people who have the highest velocity from a development perspective are also the ones involved in a war room or in an emergency problem-solving session. And last but not least, if your teams are not truly autonomous and the platform team is every time still involved, or the SRE team or the experts, ultimately that slows down the entire organization. And that's also really important, for the platform team, for example, they can then not focus on building out a very robust, modern, cloud-native platform. So if there is IT impact on knowledge, on data access, on the lack of skills on how to set up an observability strategy, and there are issues, that's then ultimately impacting the business. And that is really what is valuable for your organization and for your company. And these 4 issues, or challenges if you like, are really continuously in the back of our minds when we develop StackState. And if I need to summarize StackState, again, there are 4 unique type of approaches that we have in mind. And you'll see that straight after this slide from Jeroen. The first one, what we believe in, is that you should, as an observability team, and in our case, a tool provider, have a way to give access to the data in a central but secure way. So there's no need for every developer to get access to the cluster or to have other admin privileges, but the data that you need is in a central place. That's one. Then second, we believe that needs to be easy to navigate that entire data structure. And what I mean there is navigate the construct, for example, of Kubernetes or other cloud-native resources. Because if you're able to quickly jump from one resource type to the other without having a deep understanding of how technically it's related, it really helps you to go to the cause of the issue as fast as possible. So we have data, we have navigation of that particular data, and we'll see how the dashboards are shaped in StackState. And then there are 2 more important ingredients, and they speak to the lack of knowledge. And the first one is, if you have all the data out of the box as fast as possible, you want to detect any issue that arises in your landscape. And with StackState, we do that with what we call monitors, or if you like, observability policies. They're pre-packaged in the product, and as soon as you flip it on, you'll get already a base control of everything that's happening. And then the 4th element, it's not only about the detection of an issue, it really is all about diagnosing and remediating as fast as possible. And that is at StackState what we do with our remediation guides. Because if you have an issue detected and all your engineers are guided in a professional way towards the cause of the issue, well, the time it takes to solve it will be shortened dramatically. And that really has an impact on your MTTR and therefore at your business reliability. So gathering the data, we also then correlate it, and we'll see that in a split second. Having all the out-of-the-box dashboards to easily navigate, detect the issues, and help the user to remediate. These are our 4 secret ingredients. And Professor Plum and myself, Colin Mustard, will show that today. And remember, it's a game. You need to get as fast as possible to the right answer to win this magic game. But without further ado, let's take a close look at the product by Professor Plum.
Oh, thank you, Colonel Mustard. Welcome, everyone. So I'll quickly take you into a journey into StackState what you'll be seeing is actually all live information. This is our open playground, which you can access during the webinar, or which you will play with during the webinar, but also after the webinar. This environment is always on and always available for your troubleshooting journeys to actually look at what StackState offers, all the latest features that we've released, etc. So when you end up in StackState, and you can actually access StackState directly through our website. I'll show you how. You can just click here, Explore Product. You'll end up in our StackState playground, and you want to explore StackState on your own. And you'll end up in this case, the services overview. So StackState has knowledge about all of the Kubernetes resources that live inside your Kubernetes clusters. And if we look at our menu, you can actually also see them all, or at least a big number of them. You see the services, the pods, the clusters themselves, namespaces in the clusters, etc. So all of the Kubernetes primitives are known by StackState and are observed by StackState. Well, thank you, support team. No, I do not need to chat with you today because I know my way around. I invented this stuff. So when we end up in the services overview, you get basically the list of all Kubernetes services. And this is the first part where we bring all the information already together. You see all the services, you see their basic Kubernetes metadata. And if we click on one of the services, let's go in, you'll actually see what we call the highlight page. And in this highlight page, we bring together all of the information pertaining to the service. All of its telemetry signals come together in a single page. On the left-hand side, you see our About section, displays the Kubernetes information. We see what namespace it's in, the cluster it's in, the IP address it's gotten, how old it is. But what we also show is the configuration. So StackState actually knows the Kubernetes YAML that's being deployed to that cluster. And why is that important? Because Kubernetes only knows this information in its most recent form. It doesn't keep track of what this was yesterday or the day before, but StackState does that because we continuously know what the latest state is. We're able to also track this over time and detect changes within there. And I'll show that later on. And next to the configuration, we also know the status. Well, for a service, that's pretty empty typically. But for other resources, there's actually also different information there. On the right-hand side, on the topmost part of the screen, you'll see the StackState secret sauce, the out-of-the-box monitors, our best practices that are included within StackState. And I'll dive into that in a minute, but I'll first explain the other parts of the screen so that later on, during the challenges, in a few minutes, you'll be able to find your way around StackState, because that's what our goal is today. You'll actually be doing live troubleshooting on your own with our curated set of challenges. I'm now walking you through the big demo scenario. So below the monitors, we actually have our events. So one of the 4 pillars of the MELT telemetry standard, metrics, events, logs, traces, StackState traces events also. We have alerts there, we have activities there, such as in this case, it scaled down, it created a pod. We have changes there. So what changed, deployments done, and other events, basically anything miscellaneous happening. And in this case, what is important is that StackState does not only track this for this service, but also for any related resource. So in this case, for instance, deployments done were not for this service, but for a deployment. And how does StackState know this? Well, actually, if we go one screen on and we expand this, StackState actually has what we call the topology. StackState knows how resources are all connected. So for instance, this add service is actually fronting an add service pod, which actually has an add service container. It has access to the Kubernetes API volume. It is owned by a replica set, and it runs in this case on a specific node. And we can expand that further and further. So StackState actually not only brings information into a component, all of the telemetry, but it also knows the ecosystem that this component lives in. And that actually makes troubleshooting a breeze, because components, services, pods do not live in isolation. They communicate with the world. They are developed in isolation by your developer, and he's unit tested it, but once it hits production, it actually starts interacting with its wider ecosystem. And that's where observability actually plays a crucial role, to actually know what's happening. It could be an environmental thing. It could be something else that's influencing you that actually causes you to fail. And that's what we'll see in this troubleshooting journey. Just sticking the mustache back. Oh, wait a minute.
Is it fake?
Yeah, it is.
What else is fake?
A lot is fake, but not StackState. StackState is not fake, because this is all live data that lives in our playground clusters. So from the events, we dove into topology, but there's more on screen, actually, because we also have metrics. In this case, this pod isn't emitting HTTP metrics, at least not those. That's weird. But there is actually HTTP downstream and upstream metrics being, that's the trick. It doesn't have any upstream metrics, but there is downstream metrics and there's network throughput. So StackState actually tracks metrics, events, logs, and as you'll see later, we also collect traces. So we do this for this service, but let me quickly jump at a pod, because I said that we also collect logs, and services don't have logs, but pods do. StackState also has the logs for the pods, and we can click on them. We actually see all of the information brought together, in this case for this pod. Somebody turned off the lights here.
It's going to be mysterious.
Yeah, it's going to be a
Plum.
dark webinar today. And what you'll see is that, for instance, for a pod, we actually collect a different set of metrics. For the service, you saw the SRE metrics, latency, error rate, and throughput. For a pod, we actually mainly track CPU usage, throttling, memory usage. And below that, we actually track HTTP metrics again. So for each of the different resources, we track different things and we highlight different things. If you want to know all the metrics, you can actually go into our metrics perspective, where you see all the metrics collected for the pod by StackState. So the APM metrics, Kubernetes pod metrics, etc. So let's dive back into our.
So yeah, just a few words. Just a few words.
Yes,
on that.
Colonel. You don't understand it?
Yeah, I do understand. Can you go back to that? So, so to solve mysteries, and a pod page is a good example to solve a mystery.
Oh.
You are already at the pod overview.
No, I was at the service overview.
We believe that some information is crucial to do the troubleshooting. However, we also include a ton of dashboards that is visible under the metric tab, but for us, they're a little less relevant. Only when you need to go really deep, you will go to the metric dashboard at the top, and then you will find a ton of pre-packaged dashboards. But there's more value, what you've just explained, in bringing the data, the events, the logs, the metrics together from a troubleshooting and an operations perspective.
Yes.
Okay. And can you also explain that related resource section? Because I do think that is really important to navigate quickly Kubernetes without knowing exactly what is.
Yeah, so indeed the related resources. Well, we showed you that, or I showed you the topology. Basically, the related resources is a summary of that topological information that's quick to navigate. So now if I want to go from this pod, I can see which services are fronting that pod. I can one click go to there to actually see that service. And from the service, you'll see that it has one pod. Well, we came from there, but there are 3 services that are actually connected to this pod, so that are communicating towards it or with it. So you see in this case, it's the front end, the feature flag, and the OpenTelemetry collector that are actually connected to it. And in this case, we see also that the front end is deviating. So let's start our journey there, because if we look at the topology, and let me quickly go back into our initial screen that shows it better. We see in this case that the topmost component of our chain is the front end, right? It's where the users end up. So if that has a problem, that probably means that users are seeing problems. Don't you agree, Colonel? That's
true. Although solving clues, we know that it might come from a different place.
Yeah, but let's start at the beginning of this journey. Let's dive into that front end component. And we quickly highlighted already a few minutes ago the monitors. Let's dive into this now, because the monitors are what StackState uses to detect health of components. And health can be green, it can be healthy, but it can also be deviating, not healthy, but also not fully down yet, or it can be critical, right? Severe problem, P1 outage, whatever. And in this case, we see that there are 2 monitors triggering. It's the HTTP 500 error ratio and it's the span error ratio. In this case, the span error ratio is about the traces. So StackState actually uses a multitude of technologies to observe your Kubernetes clusters. On the one hand, we have our eBPF agent, which lives on the cluster and actually gathers all of the deeper kernel level metrics. It gathers the cluster API information, but StackState also utilizes OpenTelemetry to actually augment that data with trace information in this case. So let's dive in here. And if we click this, we'll see at the top of our screen a small description of, okay, what is this monitor? It monitors the percentage of spans that have an erroneous state. And you see how this evolved over time. So sometimes this is green, sometimes it's orange. That's because it's our demo scenario. We run it in a green scenario and in an orange scenario alternating. So, and in this case, we dove into the timestamp at 11:15, roughly 13 minutes ago, where it was orange, so that we know we're in a demoable state for today. That's also a good thing in StackState. You can actually travel back in time. You can see what the state of your system was at a specific point in time. So in this case, we ended up at 11:15 because that was our demo time. And below that, we actually see why does StackState think that this monitor is in an unhealthy state. You see that during the orange period, it actually was spiking. And at the end of the orange period, it actually went down to 0 again. This metric is actually the error ratio, the span error ratio. So the number of spans that were not erroneous versus erroneous. And in this case, it goes up to, well, almost 2%, 1.5 to 2% of spans that are in an error state. So 1.5 to 2% of the users are seeing errors on their requests currently. So, well, that's all nice and dandy, but how are we going to solve this? Because these users, we don't want to lose them. That's where StackState brings in the remediation guide. Every monitor in StackState actually has a remediation guide attached to it that tells you what is wrong, how to troubleshoot this, and how to try to resolve it. So that we were talking about, or Colonel Moster talked about, those users who are not Kubernetes experts. How would they actually need to solve this? They developed this application, now it's interacting with that ecosystem. How to actually solve the problem at hand, because the platform team, that SRE guy, he's overloaded. He needs to maintain that platform. He needs to enhance that platform. He can't do this all. That's where we actually bring in those remediation guides. So, and in this case, we say, okay, what are the possible causes for this? We'll start from the top. It might be a slow dependency or a dependency serving errors. StackState then helps you say, okay, how to troubleshoot this? Well, there are two ways to find the root cause. Analyze the traces. Let's click the link. And when I click this link, what happens is StackState actually goes to the right point in StackState to actually troubleshoot this, but also on the right-hand side, you see the same remediation guide now pinned to the right-hand side of your screen, so you don't lose it. It is still in context. There's no need to write all this information down and, well, basically copy-paste the hyperlinks that are all in there so that you can do that troubleshooting journey. No, the moment you actually start your investigation journey, StackState helps you by keeping this, well, run book in context, the remediation guide. And we can say, okay, expanding a span will show the full trace. Well, let's do that, right? So we expanded that span, and we see in this case that there was an HTTP GET done to the service, to the front-end service, the green one, that resulted in an error. Well, there was a call underneath it that actually resulted in an error. And then there was the add service get adds that actually resulted in an error. And nothing below that actually was erroneous. So let's look at our remediation guide says spans that have errors are marked. If you find an erroneous or slow span, you can follow the link to the component to continue the investigation. Well, let's do that, right? I click that span, and we now see on the right-hand side the details of that span, and we see that that is actually connected to the add service pod. So it's a different component. Let's dive in. Oh, no, I didn't want to close that. I wanted to see the remediation guide again. Were we at the end? Yes, continue investigation. Okay, how do we continue the investigation in StackState? Well, you guessed it. Have a look at the monitor. It's another span error ratio. So in this case, this service is also sending out error spans. Well, we know for one that it doesn't have any dependency serving errors because we didn't see any errors down in the previous span that we looked at from the front-end service. So let's have a look at the second possible cause. It is a recent update of the application. Well, is it? Well, if the pod was recently created or updated, go to the events in the middle of the pod highlights page. Well, here we are. Add service pod highlight page. Let's scroll to the right place in the remediation guide. Check if there was a recent deployment by clicking on the deployment section. Events, deployments. Now let's quickly have a look at what time frame we're in. Oh, we're at 12:53. Were we actually? Yes. So let's have a look at the deployments. Now 12:25. So there was a deployment done at 12, so roughly 25 minutes ago. Let's have a look at that deployment. So StackState, as I said, tracks all changes that are done. So if we now view these changes, we actually first see that it wasn't a deployment for the add service. It's actually the feature flag service. So by combining our correlated information, knowing what all is connected, we actually already said there was a deployment connected to the add service, but it wasn't for the add service. It was actually the feature flag service that was being deployed. And we see that it was actually deployed with a new version of the feature flag demo service. And if we now try to correlate this time, we actually see that around that time of that deployment, also that monitor turned orange. So, a good indication that in this case, deploying that feature flag service actually did something to our ad service, and in respect to our front-end service, start surfacing errors. So in this case, a deployment of a service, and that service itself, if we look at our topology and the pod, that pod is not in a problematic state currently. It's fine. However, its new version is acting differently, causing our ad service to fail. Because the moment this was deployed, we actually see the error rate going up. And what I did is I highlighted a point in time. And if you now look at the different charts within StackState, you'll also see that that point in time is highlighted on all of them, allowing you to easily see what all is going on and try to further corroborate all the evidence.
I just want to make a remark, Professor. I do think they learned a lot.
Did
they learned enough. There are a lot of people joining here to do workshops themselves and to show the mysteries. What are the final two things that I need to know before they can act themselves? Or are we ready?
I'd say we're ready. I think the one thing you need to remember in StackState is everything is about the monitor. StackState helps you by monitoring out of the box over 40 different kinds of best practices currently. So going there for any of these challenges that we're going to do, start by looking at the monitors. There's a ton of information on the screen. It all helps you towards finding the root cause, but it starts with the monitor. Perfect. I think that's the gist of what you need to learn about today.
So can I be your assistant for a little while, keeping an eye on the time when people start looking into? We've touched upon these. These are the investigation tools that StackState provides out of the box. So thank you for going over them. Let's get to the first challenge.
Wow, the challenges. Well, before we start these challenges, there are some, things to know, right? Before we start. First one is the link. Where should you go? You should go to l.stackstate.com/challenges-2024. Don't forget the 2024, else you'll end up on a different set of challenges for last year's webinar. We keep these alive so that you can do these tomorrow, next week, next month again, show them to your colleagues, whatever, because we hope, of course, you like StackState so much, you'll actually tell your colleagues, hey, look at this cool tool. So they're there for you to always enjoy and do the troubleshooting. We've created, we'll do 5 challenges. There are a few more in there. You can do this on your own after the webinar, but for the webinar, we'll do 5 of the different challenges. We'll go over them one by one, and for each challenge, you'll get roughly 2 minutes. We hope that's enough. If there aren't enough hands or votes, we'll keep the voting open for a few moments longer, but typically they're done within 2 minutes. And when you found the problem, I already said vote. Please answer in the poll window so that we can keep a track of whether you found the issue and what's happening and whether we can continue or not. And then we'll go over it as a group and show you the evidence that actually StackState used to determine the problem. Right?
Excellent.
So without further ado, go to the link and then I'll open up the first challenge on my screen.
It might be that some of you need to fill in an email address once. If that's the case, just enter your Gmail or your company mail, and then that's the only thing, and then we can get started.
Yeah, and don't forget, after like 30 seconds or something, the support team chat comes online. You can just close that.
Yes, for now.
Because we're in the webinar.
Yeah. If you have questions, feel free to drop them in the Q&A section.
Yes, Colonel Mustard will actually be happy to answer them. I can't because I'll be presenting. So our first challenge of today is Mrs. White's dilemma with the wrench. So I'll open up StackState. quickly.
I'll, by the way, also paste the link. Oh, thank you so much, Genevieve. The link is already there.
So
Yes.
it's the third, in this case, if you open it, it's the third one. And if we look at what are the possible answers that you can vote for, it's either the container image does not exist, you cannot schedule the pod readiness probe fails, or it was an unyielding wrench attack.
I think the last one.
Yeah, it's the last one. Someone was attacked with a wrench. It's probably Mrs. White.
Yeah.
You remember her?
I don't hope Miss Scarlett.
No.
I hope she returns.
I hope our Miss Scarlett isn't being attacked with a wrench, else we have to save her.
Can we pull up the poll so people can now go to the playground?
I'll start my investigation journey also.
Yes. I'll smoke another pipe.
Hey, there is the poll.
There are the first answers coming in. That's absolutely good news. Someone really believes the wrench is the cause of the issue.
Yes.
Can we keep the poll open a little longer? If you're still alive, Miss Scarlett, rather than the... Okay. Oh, it's going up the timer.
Alive, and absolutely yes.
Yeah.
So it's, I hope everyone is enjoying this. I know we are.
That's for sure. There's another minute to get this done. And then Jeroen will go over it.
I can actually see the question. Did you answer the one from Venkat?
I did.
Is it open source? Well, it's actually a good question, right?
We can answer that here as well in the group.
Yeah, well, so while you're answering it.
So there are a lot of open source components in our product. The product as a whole is not open source as such. If you want to try it, there's a very extensive free trial. 14 days on the website, 30 days in reality, and if needed, we can extend that a little longer. So drop another question if you would like to chat on that. All right. Many answers came in, so that's really nice. I hope you enjoyed it. More than 50% of the participants ultimately voted, and I would recommend you, after you've seen Jeroen doing it, just do it yourself. 47% thinks that we cannot schedule the pod. Someone thinks still that it's the wrench. That's really sad to hear. But
why? It could be the wrench.
Could
but we haven't figured it out yet, right?
And that's absolutely true.
So I don't know who can close that window, because I can't. Thank you. So, well, let's Mrs. White's dilemma. So we end up in this pod. We see that this pod hasn't existed for a long time, since 9 o'clock this morning. These challenges are refreshed 2 times per day, so that they're always actual. And some people voted for the readiness probe. Well, yes, could be right, because the pod is not in a ready state. That could have been the readiness probe. However, if we open up the monitor, we'll see actually that StackState provided you with a reason already. So if the monitor actually is able to figure out a specific reason, it is actually immediately displayed there. So in this case, no nodes are available. 1 node had a taint, it was the control plane node, and 2 nodes actually had insufficient CPU and memory. So in this case, the pod could just not be scheduled, because, well, let's have a look why this is. So there were untolerated taints on the one hand side, and 2 had insufficient CPUs. So could it be due to node taints? Yes, for the 1 node, but that's a control plane node. So typically you don't want to schedule too many workloads there. So it's not the node taints. Insufficient resources. A pod requests more CPU and memory than any node has available. Yes, in this case, that's the case. How do we actually see what that is? In StackState, we can go to the configuration. So if we then scroll through this configuration, we'll actually somewhere see resources, and I always need to be able to read. Here it is, the resources. So this pod actually requested and limited 16 CPUs and 128 gigs of memory. Now, and I'm pretty sure that our cluster isn't that big.
No. We always save cost.
Yeah. That's a good thing, right? The playground runs on a very small cluster. So in this case, the pod could not be scheduled, basically because it was requesting so many resources. This is probably a very complex system that it just can't be deployed on this cluster currently.
So help us out. What's the right answer here?
The right answer was it could not be scheduled, which was, I think, answer C or
Answer
B?
B.
Answer B.
All right. Thanks a lot. This was the easy one because the reason was given. Let's go quickly to our second dilemma.
The second dilemma, Mr. Green's survival in the conservatory. Well, in this case, it could either be that the pod was CPU throttled, it had too many changes, it was expired by using a lead pipe, or the pod has too much traffic going towards it.
So let's go back to the same link, l.stackstate.com/challenges-2024, or just click back in your browser and then you end up at the screen, or use the main menu, views, challenges, and we'll start a timer and give you another 2 minutes to get to the answer. 2 votes are in already. That's amazing.
No, either those people are very, very quick.
Take your time, make use of the hint. The remediation guide is often helping you out. Excellent. You actually have a favorite room?
Including?
Yeah, where you would like to go to?
The conservatory.
Yeah?
Yeah.
I like the library.
Yeah, you like the library. Yeah, I like the plants, you like the books.
Yeah. It's wisdom. Wisdom we need to gather.
Yes. But there's a lot to learn from nature. Actually, nature it's also a complex ecosystem.
That's true. Looks like Kubernetes, if you think about it twice.
It's like Kubernetes. It's like the post I did yesterday on LinkedIn.
On the clouds.
Right? On the cloud. There was actually this beautiful shelf cloud floating by, and I thought, weather is just like troubleshooting Kubernetes. Because there's so many different factors that come into play that interact with each other.
Yeah.
It's same as a Kubernetes cluster.
Yeah. Really interesting to see. More people are feeling confident to get started because more people are voting compared to the first one. So I would like to challenge you for the second and the third. It also very well might be that the first one was a little too short, the time, but let's give it another 20 seconds. Really good to see.
Yeah, somebody, at least one person thought that the pod was hit by a lead pipe.
Oof. More than 60% voted. All right, let's get to the answers.
Yes.
Yes. What are the results?
Well, the results are in. Well, the majority of people thought that the pod was CPU throttled. And then close second and third is too much traffic and too many changes. And then probably 1 or 2 people voted for the lead pipe.
All right, let's close the poll. I'm conscious of time. I really would like to do another 2 challenges after this at the minimum.
No, I went to the wrong one. If you go into our left-hand side menu, there's no need to always click type the link back. You can actually go to the Cluedo 2024 challenges. So we were for Mr. Green's survival in the conservatory. Well, monitors are leading, right? That's what we're saying. In this case, there are 2 monitors triggering, both the CPU throttling and the span duration, which are, of course, highly interlinked. If a pod is being CPU throttled, it will actually not have enough CPU available to timely respond to all of the requests coming in, so that spans, the traces, will become longer, triggering a second monitor. In this case, CPU throttling. Well, the monitor name actually already gave away the answer. In this case, we'll look at the metric. It's a threshold. If it goes over 90% CPU throttling, this monitor starts alerting, and you'll see that it's actually higher than that. What do you do to remediate this? Adjust CPU requests and limits. Probably this one is set so low that it can't deal with all the traffic coming in. Yes, it has a high volume of traffic, but it's actually solvable by adding more CPU resources, ensuring that it's no longer CPU throttled.
Excellent. So, pod is CPU throttled.
Pod is CPU throttled, which was A.
Excellent.
All that voted A, hooray, you're ready for the next round.
If not, it's another attempt of just practicing.
So, Professor Plum's transparent secret.
Yeah, this is all about you, my friend.
This one was a special one of mine. So either in this case, the secret data is not secured, the certificate is self-signed, a certificate is expired, or there was a secret weapon which is undisclosed. Well, I love that secret weapon, but in this case, I didn't use a secret weapon.
Go again to Professor Plum's pod, or to the resource, and see if you can find it. The first answer.
Yeah, well, so I think it's nice in this case. You said pod, but in this case, StackState does not only monitor pods and services. We're actually able to add monitors on top of any of the Kubernetes resources. We have monitors on nodes. We have monitors on the cluster, but also on config maps and secrets, we can put monitors. So StackState does not only monitor based on metric data, we can also monitor on other forms of data that StackState knows about.
That's absolutely true. What I also really like with this challenge is that it demonstrates how easy it is to integrate other small tools that you already have in your ecosystem with StackState. And yes, I'm sharing a little bit of the outcome, but it's important to understand that StackState owns some of the core data, but that you can utilize that data to not only take a look at reliability from a health and an uptime perspective, but also from other angles. All right, there's still good answers coming in. Couple more seconds.
There's 47% voted. Well, do we hit the 50% mark?
We are.
Yes, so we hit the 50, 53. Well,
interesting. No one thinks that it's a secret weapon.
No, no one thinks it's my secret weapon, which is good, right?
I know your secret weapon, my friend. I've experienced it numerous times.
Yep, but in this case, we didn't deploy any secret weapons. Hey, there is our poll with 60% of the people voted. A whopping 68% of the people think that secret data is not secured. Another 21% of the voters thinks that the certificate is expired, and 11 think that the certificate is self-signed. Well, let's have a look. Oh, that's the wrong one.
Okay, let's close the poll and see what's out there. There we go.
Yes. So that was the transparent secrets. Let me quickly remove the window. In this case, oh, we are still actually monitoring the pod. I had a different one in mind.
Similar to me, man.
Similar. So there is a secret finding violation. What this does, actually, this monitor, well, I said we monitor different resources. In this case, we're actually also, StackState integrates with a ton of different sources. I told you about our agent that uses eBPF, access to the cluster API. I told you about OpenTelemetry, but we're actually able to also integrate with secret scanning tools. For instance, in this case, Git leaks. So we have Git leaks running in this cluster, and that actually is connected to a monitor to actually see whether there are secrets exposed within the cluster. And in this case, within the pod. So we see, in this case, no metric. However, we see cause and impacted components. We see a pod and we see a config map. So StackState actually is able to see how that there's a problem cluster in this case of related violations. What does the remediation guide say? Well, there is a hard-coded secret detected. And in this case, it's a secret key for OpenAPI. Somebody actually accidentally put his ChatGPT key there.
Ooh.
Colonel Mustard, I'm assuming that's you.
I barely use ChatGPT, my friend.
You barely use ChatGPT. Yes, you use the library, right?
Exactly. I have all the knowledge myself.
Okay. So somebody put in his public key or his private key for OpenAPI, his access token. And GitLeaks triggered on that, reported a health violation to StackState, triggering this monitor. And StackState shows you how could you better do this. You create a secret, put the data in there, and relate that to the pod. So in this case, everyone that voted A, secret data is exposed, was actually right. And I said we don't only do this for the pod. Indeed, we can also do this for the config map. So on the config map, you'll actually see a different one. There is a generic API key there that's detected. And uh-oh, suspect is Colonel Mustard.
Or Miss Scarlett.
Or Miss Scarlett. Sorry, Miss Scarlett.
It should be Miss Scarlett. Yes.
So indeed, people that voted A were right.
Conscious of time, because Miss Scarlett is coming in for a reason. I really want to do the fourth one, and that's probably the last one, because this one is really nice, and probably you can just demonstrate it, and then people can do it themselves.
Yes. Is it that time already?
Yes.
Okay, I'll dive into it. It's Mr. Peacock and the Abandoned Vaults. Sorry, guys, you won't be allowed to vote. But where is Mrs. Peacock and the Abandoned Vault? Well, this is actually a different resource than a pod. It's a persistent volume claim. In this case, what we detected in StackState, like I said, we don't only measure metrics, we don't only have external signals from external tools that we can ingest for health. We also can monitor topology because StackState knows relationships, knows how the world is connected. We can actually also see whether there is a connection missing that we expected, or whether there's a connection too much that has been forbidden. In this case, the persistent volume is orphaned. So there was a pod that had a persistent volume with a persistent volume claim, and that pod is now long gone. However, the claim was never deleted, meaning that the persistent volume behind it was also never deleted, potentially leaving behind sensitive data. This is a compliancy risk typically in Kubernetes if that goes on for a long time. This can happen, of course, shortly during deployments, for instance, but once you remove the application and data is left behind on your cluster, you can actually consider that a compliancy or a security risk, because you never know what's there for attackers to actually gain from you. So, oh, that was accidental.
Gentlemen, I have to be cautious about the time. We have only 2 minutes.
Miss Scarlett, no, don't hit me.
But thank you. I see why you're very excited about this, and I would encourage everybody to continue tasks at home or challenges.
Yes. I'll go to the last slide, because that's what you were hinting at, right? Yes.
So what I really recommend to do all the challenges yourself, and feel free to reach out to Jeroen or me anytime.
Absolutely. I would just like to announce the winners of 50 euros Amazon gift cards that the vouchers too after this webinar today, based on the answers that they were given. And I'm really sorry in advance if I'm not going to pronounce names properly, but it's Trond Winders, it's Alain van Hof, it's Daniel Anthony, and Gianpaolo Macario. You are going to be receiving vouchers on your emails. And all of you will be receiving 5 questions surveys and about your experience at the webinar. And I would really thank you and appreciate if you would fill them up. I genuinely hope that you enjoyed solving mysteries, and I would say goodbye until the next time around. Thank you, gentlemen.
Until next time. Don't forget, using the QR code, you can actually request your free trial to try StackState with your own data.
Exactly.
Adios.
Bye. Bye, everybody.